exam, and then the highest grade would be 10. So we are all trying to be reasonable. So hopefully we can let's go through our first exam and see how it goes, and then we can if you folks think it wasn't reasonable, it was too hard, or a curve was necessary, we can always come back to that. Okay, so that's that, and let's now talk about our actual topic, and that would be differences between C and C++. Okay, and okay. All right. So we in this class we are, as I already mentioned, we're going to be using C, and C is not the same as C++, and you know quite often students would learn C first and then learn C++. So go from an older language to a more contemporary language with more features and object oriented versus imperative. But with most of you, it's actually the opposite. So you first learn C++, kind of more beefed up version of C, and now we will need to talk about C. Why do we use C in this class? Well, because it is generally considered to be sufficient for the tasks that we will be using this language for in this class. We are not going to be focusing on object-oriented features, so we don't need all the complexities that C++ has associated with those features, right? We're not going to be using classes, we're not going to be using templates, we're not going to be using streams, so we are going to stick to what is known as plain old C. So C does not have any classes, so all code is in functions, and C does have structures, but structures cannot have methods, unlike in C++. So all I/O is done by calling library functions instead of streams. So you do not have your favorite C in, C out. You have to use functions like printf, scanf, and a bunch of others that we will go over. C does not support any function overloading. So that's something that you almost take for granted, right? You have overloading functions in C. You have overloaded methods in Java. This is not something that existed in plain old C. So you cannot have two functions with the same name, regardless of whether whether formal parameters are the same or not. Okay, so and I know it's something that I even try to do occasionally. It overloading seems so intuitive to me that I often forget that C does not have overloading. So all right, so similarly, memory management is done by calling functions. So those functions are malloc to allocate memory, memory allocate, and free to deallocate memory. So there's no new, there's no delete. You have to call those library functions malloc and free, and you will see that there are other functions in the same family. So malloc is not the only function. There is an entire family of allocation functions. So you have to call those functions for memory allocation and deallocation. C does not have reference variables, so there's no ampersand to denote a reference variable, unlike in C++. So is there anything similar between C and C++? Well, likely there are quite a few similarities. So historically, C++ grew out of C, and actually the first name of C++ was not C++, it was C with classes. And then shortly after, it became known as C++. So all built-in data types are the same: int, double, character, and so forth. All preprocessor directives are the same: include, define, and so forth. All basic language control structures, all your favorite keywords: if, while, do, for, they are all the same. Switch. All operators and their precedence is the same. So plus, minus, and this whole set of operators is the same for both languages. So there still has to be a function named main in C, as there has to be in C++. So function definitions are done the same way. And in C, there are actually several different versions of the standard, and they vary. You know, some versions vary of the standard very slightly. Some versions vary more significantly. So the very first standard of C, which wasn't really a standard, but which is known as Kernighan and Ricci C, K and R C, is had significant differences from what is known as ANSI C or later standards like C99, and exactly how function definitions are done. So and we assume for our for this class, for all intents and purposes, we assume that we're using ANSI C or older. So if you try to write your C code using the Kernighan and Ricci original standard for C, it may not compile. So and their overall organization of code, of source code, is the same in C as it is in C++. So you can have code, source code in multiple files. You can compile them separately and then link all those compiled modules together. And here is their evolution of C. So traditional first C, which is not even a standard, which was just a de facto industry standard because there was a compiler that implemented that dialect of the language, dates back to almost 40 years ago. Well, more than 40 years ago. So this is K and R, Kernighan and Ricci C, and it's not by accident that K and R, Kernighan and Ricci, those two people are the authors of one of the books that I mentioned before. So apart from our required computer organization design book, we also have their supplementary optional books that we recommend as references, and one of them is the C programming language by Kernighan and Ricci. And then there was an 1988 standard ANSI, which is the minimum that we recommend that you stick to. And there were a bunch of later standards, C89, C99, and then more. There's a bunch of more current as well. All right, yeah, let's briefly go over the differences between standards. So C89 compared to their Kernighan and Ricci 1978 C introduced a bunch of new keywords and it introduced function prototypes. So argument types could now be specified in the function declaration, and whereas previously in Kernighan and Ricci they were declared separately. And then their C95 standard added some new standard library headers and new formatting for printf and scanf, and we will talk about that as well, and introduce a large number of new functions. And then C99 is probably and arguably the most widely used C standard these days. It's old enough to be compatible with pretty much everything, but it is still fairly modern. All right, so here is a simple C program. You can see printf is what you use if you want to produce output on the console. And so let's see how you compile and run your code. So I have all those examples. here. So you just do GCC and then the name of their source code file, and that's the bare minimum. So if you do just that, it will create a file called a.out. This is an executable that contains your code ready to run. So you can do a.out, and here we go, you run it. So this is the default name. Of course, it's not particularly meaningful. So quite often you want to specify their name for the output file that you want instead of a.out, hello world, for example, like that with a -o flag. And now you can see that this hello world has been created, and now I can run it. So in Linux, to run it, you start with a dot, then slash, and then you do hello world, and here it is. All right, so here's another version of hello world. So that demonstrates a loop. I'm not going to run it for the sake of time, but you have their source code for it. So please, please, run this example. Make sure that you can run it. All right. And is this following program a valid C file? Yes or no? Well, no, it's not 10 minutes, 495 slides. No, we're not going to cover the whole thing today. No, why? Why not? Exactly. This ampersand, it's a reference. There are no reference variables in C. Right? It's not your C++. In C++, that would be fine. All right, so here's a typical anatomy of a C program. It's very similar to C++. We have include directives, we have defines or any other preprocessor directives. Then we may have type definitions, type def, global variable declarations, and then we finally have functions. So here we have a reverse function and main function. We have to have a main function if we want to run our program. All right. And C programs can take command line arguments, and then they can treat that command line argument as a string, right? Because they don't know what it is. In this example, we want it to reverse the letters in a string and print out the result. So here's the code, and the source code is in your lecture notes so that you can run it anytime you want. So this is the reverse C, and right. So basically, that's the same code that appears in their slides. You can see it here, and we can compile it, and then we run it. And you see that it is smart enough. It figures out that I didn't specify their argument for the command line, and so if I do specify then the argument, then it runs. So you can see how you access the arguments with this array argv, argument values, argv. Okay. What if I want to have the string with several words separated by space? Well, you see, it does work like that, right? Because it treats these two words as two separate arguments. So if you want their shell to treat them as a single argument, you have to enclose them in double quotes. And here we go. So how does input work? Here we have their command line argument conditional code that checks to make sure that we have at least one command line argument. So why is it less than 2? Well, because 1 is the name of the program itself, and the second one is our argument. So we need at least 2. That's why if it's less than 2, we print that the program is not used properly, and we exit. And if their command line argument is successfully supplied, then we are going to reverse the string by using an additional buffer, this buff, and then we copy the string by using the library function strcopy from S, our original string that is coming from the command line, to the buffer. The class ends at 150, so we are exactly at our time limit. With that, we didn't go over all the slides that we were planning for today, but there were many questions about their syllabus and the schedule and the like. So I will make sure that I ask our TAs to go over those examples in particular, so that we covered, but you will need a little bit more detail about printf and scanf for your labs. So please make sure you show up in your lab at the very beginning, because TAs will go over these two functions before the labs. Does that sound good? Okay. Thank you. Yeah, if there, so we have to stop here. If there are any questions, please ask them on the Submiti forum, and one of us will make sure to, to follow up with you. So thank you for attending this lecture. Good luck tomorrow with the lab. Keep us posted how everything goes, and see you on Friday in our next lecture. Have a great day, all of you.